Hello, everyone. Welcome to How to Reduce SLS 3D Printing Costs webinar. And today with us, here is Kuba and Marius. Kuba, may you introduce yourself?
Hello, I'm Jakub Malec. I'm an application engineer at Synterit, and I work with advising clients with the best solutions for them and the best materials. Also, I prepare simulations for clients and prepare their samples.
Okay, and thank you very much, Marius.
Hi everyone, my name is Marius Hebler. I am the product manager for services within BSF 3D Printing Solutions, located here in Heidelberg, Germany. And as a product manager for services, I'm responsible for the design and simulation services, as well as the cost per part analysis. So within these functions, I'm very happy to join this webinar and discuss more on the SLS reprinting costs.
Thank you very much. My name is Jarosław Pieniążek, and I used to be a marketing director in Synterit for the last 4 years. Now I'm taking over the new role, business development director. So I'll be responsible for grow the overall business and technology development. And okay, let's start with some technical aspects. First of all, during the whole webinar, you can ask questions. Just please use on the right column, the chat column, you have like separate questions tab section. Please use this one for questions, and during the live questions part, we will try to answer them all. Okay. What are we going to talk today? First of all, SLS advantages. So all the advantages are connected to cost saving. We'll try to give you a more view on how SLS saves money, and also very important part, how to calculate cost of printing, which is not really a easy thing in SLS, but I hope that Kuba will explain it really good. And then we'll get into Q&A session, and there are some already asked questions that you ask using the form and email, and then we'll get into open questions. Okay, first of all, what are the costs of 3D printing? So we have like what we can treat as a cost is, first of all, time. It's very important. I mean, it's a time that you consume for labor, for printing, or whatever, and time is always money. The printer itself, the cost of the post-processing, the maintenance, material, labor, and power and depreciation. Power and depreciation we can address in just in a reduced part, but the other we are taking over in our offer, and we'll try to show you up how we handle it. First of all, time. What are 3D printers made for? Many will answer fast prototyping. Yes, and with Lisa X and Niels, especially with Lisa X, this is the fastest compact SLS printer ever. You can have a super fast prototyping. No time wasting before the production also, like injection molds. If you go for small batches of production, there is no time before, just pre-production time that you really save with 3D printing. And you're also ready to implement complex shapes. It's all about the isotropy that you can achieve with SLS technology, and high productivity. So it's also kind of the way to save time and money. And solution service takes little time. It's really like very easy and low time consuming. What's more, the printer and post-processing. If we consider it, most of the time you're just thinking about the printer price. It's also the post-processing cost. But what is really worth to be considered, the printer effectivity and the post-processing effectivity. We'll get a little bit deeper into it with later on. And so what we will talking about, it's our two new printers, Lisa X. This is like the most flexible solution in our offer, the fastest compact SLS on the market, that you can have a wide range of materials, so you can switch from one to another in very easy way. You don't need to separate printers, you just can use one, and the changing over and the cleaning the printer, it's like 5 to 15 minutes only, so it's really fast. And the cost of the printer is really low, and it's the lowest in the segment. And also, what is very important, it has all the benefits from Lisa and Lisa Pro. So open parameters that you can set over 30 parameters with your own to achieve better results of printing, or just use the third-party powders. And it's very easy to maintenance. But what is the most important part is the effectivity of this printer regarding the powder refresh ratio, and but Kuba will explain more about it later on. And and also the news, our first industrial machine. This is a whole new level of automation in such a machine, that the most important part is this is a production machine that can constantly work for 2 weeks before you stop it just for simple cleaning. All you need to do is just pour the powder every 3 days and collect the freshly printed cake day after the day. And it also have the extended cooling chamber that allow you to print over the weekend, and in Monday morning you have 2 prints ready to be collected by you. So it's like 7 prints a day, and constantly working during the whole year, which is very, very important when we are talking about the effectivity. Also the labor cost of this machine. I mean, it's so simple, and there's no hidden costs like agent or whatever. And then, I mean, the maintenance cost of this machine is really low. So it's all affects the cost of the part. Okay, and we get into very important part, the powder costs. But what is the real powder cost? First of all, in SLS, what is very important, after the first run, it's not about the printer. I mean, it's not about the powder cost, it's about the fresh powder. You just need to refresh the used powder and just add some fresh powder. So it's all about the fresh powder, really, in SLS. And what's the very important number is the percent of refresh ratio. In our offer with PA12, you can achieve 22% refresh ratio, which means that basically if you have the optimized bed, you just use the powder that you already use for the parts. You just add the powder that you already use for the parts and start another print with no leftover powder. Kuba will try to explain a little bit more deeply, but taking into advantage, it's not the as I says, it's like not 130 for kilogram of the powder. It's 29 euro for kilogram of the powder that is already refreshed. This is the real cost of the printing powder. So if you take a look at the others, it's like we with PA12 were able to achieve 22%. The other competitors have 30 up to 70% refresh ratio, which makes the parts more expensive. And with TPE is 10% and 0% for TPU. And we are also getting into very important materials, the PA11. And from BSF, Mariusz, can I ask you for some explanation?
Yeah, thank you very much, Jared. So currently there are 3 different PA11, so polyamides 11 in the portfolio using for these sinterate machines. We have the PA11, all of these are bio-based. The PA11 is especially good for durable parts with exception high tensile strength. You have the PA11 ESD, so this is especially interesting for applications within the electronic industry because of the electrostatic discharge. And then you have the PA11 CF, CF standing for carbon fiber. That is a powder that is exceptionally high in the strength and the lightweight design. All of these come with different refresh rates, as you see on the right side, anything from 33% up to 60%.
Okay, thank you, Marius. And what is very important, I mean, with this refresh rate, you can constantly keep the high properties of the printout. So it's like something very important, especially regarding the PA11, as most of the clients, they have high expectations on PA11 because of its durability and special applications to be covered. Okay, post-processing efficiency, this very important part. I'm giving the floor to Kuba.
Okay, so with our post-processing solutions, we can achieve very high levels of powder recovery. Basically, we can recover almost all the powder we used for the printing, while our competitors usually allow us to recover only 80% of the powder used.
Okay, and now optimizing the fusion space.
Okay, this is a very important part of optimizing the cost of the parts. As you can see in the picture, we have 2 very similar builds. The main difference here are the parts around the big parts, the air filter housing. Let's see how can we easily increase this capacity. Here we have initial setup with 3 parts. First, we intended to print them separately, but we can print them together to decrease the printing time and powder used for this print job. We need to start with tilting the big model, the air filter housing, so it fits in our working area. Okay, that should be quite okay. Okay, and we need to tilt it in the other direction because it's quite a big model. That should be about right. Okay, maybe too much, a bit. Okay, great. It's always a good idea to move the models to the bottom so we don't print any empty space at the beginning of the print job. Let's see. That looks very promising. Okay, let's move to this other parts. Let's start with the main body for the water pump. And let's move it to the front of the air filter housing. I see there might be some interference between the threads on the air pump and the air filter housing. So let's move the motor around 180 degrees in the Z-axis. Okay, that looks a lot better. Let's see from the side. Maybe we should move it down a bit. Okay, let's see if there is any interference, and it seems there is none. Okay, that's great. Let's see, let's stack some of this model. I think we should be good with 5. Okay, let's preview it. Oh, but it's a bit high, so let's get them a bit closer together, I believe. That should do the trick. Okay, now I see the parts are a bit above the air filter housing, so let's move them down. Let's see if we can do it. Okay, and let's see for collisions. No collisions found. Great. Let's make a visual check. Great. That looks fantastic. Okay, let's now move to the last part. This one is a bit different, so we need to rotate it in y-axis 180 degrees. I think in z-axis might be also beneficial for this particular positioning. We will need to place this one behind the air filter housing, the big one. So let's move it to the bottom and change to top view. And let's move it to the corner. Okay, we need 5 of these. So let's go with 3 layers and 2 columns. Okay, let's preview. That should be great. Okay, let's see how does it look. Now I can see there's might be some interference. Let's see. Okay, 3 models are colliding, as you can see in this red marking. We don't need 6 of them, so we can remove one, and let's move the other so it doesn't interfere with the big part. Okay, that's great. And that's how we can very quickly increase the capacity, the percentage of the volume that the models occupy. We therefore decrease the printing time per model, and we decrease the amount of powder we need for this print job. Okay, to sum up, decreasing the amount of powder we use by increasing the amount of models gives us the lower cost of the parts. We also, by increasing the amount of models, speeding up, because we don't need two separate builds to print the same amounts of model, and we get a larger volume, larger amount of models in the end, which is crucial for production, for example. Okay. Here, now let's see some examples of ROI, and let's start with a small production of small parts. So here we have caps for steering fluid reservoir from one of our clients, and in one run we can print 140 sets of these. Basically, these parts cannot be any longer purchased, even from China. So our client based their business model on producing these parts for vintage cars. We have 140 models. We can build them in only for 2 hours, and we can reach very high pack density of 13%, almost 14. The cost per part ends up really low because it's under €1, this cost of powder, and the entire build with the refreshing cost €149 and 11 cents. This one you've already seen. This is much the same that the example in the example of positioning the models to increase the capacity. Here we are focusing on the big parts, so production of the big parts, but also we can fill in the space with the smaller parts. Here we have 11 pieces basically of models with a printing time of 21 hours. We can even further increase the capacity here because we have some space still left. But the important thing in this example is that the entire build with all these models cost 250 euros and 80 cents in polypropylene. Without the smaller parts, the air pump parts, the price wouldn't be much lower at all. Okay, prototyping. This is very important aspect for SLS because we can print many prototypes in one run. We can change these models slightly, so we can test slightly different prototypes, and we can have these 4 examples in only 21 hours, basically. This is also the cost of this run is only 200. This is in PA11. It's only 212 euros, while the molds for the prototypes can cost tens of thousands of dollars. Okay, and the final part, maintenance of production. This is quite important for many of our clients because not all the parts can be easily obtained, and the costs of suspending the production also is very high in many situations. So our clients choose to print their parts, their spare parts, then with very quickly and with low cost, they can have the parts that would otherwise need to be purchased and delivered from various places in the world. The cost of the models and of the runs you've seen are basically cost of powder. There are some other costs that you need to take into consideration when you want to precisely price the models. You need to take into consideration, for example, electricity cost, labor cost, and depreciation. These are the major factors for the final cost of the parts. Okay, Jarek.
Okay, thank you. And yeah, that was very important. You can always ask Kuba, contact Kuba to prepare the special return on investment calculation that is based on your application, on your models and your requirements. Okay, and the solution costs. This is also a very important part, as we mentioned. First of all, the Lisa X as a solution. So it contains all that you need for printing and the whole post-processing with dedicated powder tools, ATEX vacuum and powder handling station, also the dedicated sandblaster and the software. It costs 29,980 euro. And Niels, our industrial machine, also contains all that is necessary for printing and post-processing, costs 60,000 altogether. Well, that's all. We get into the questions. There are some questions that you asked before. We'll try to answer them now. Okay, the first question, what are the major costs driven in SLS? And I think Marius will help us.
Perfect. Can you hear me very well?
Yes.
Okay, very good. So yeah, that is an interesting question. The major cost drivers in SLS. Kuba already explained it before a little bit. What is the cost structure at the LISA? But in general, what the cost structure of SLS looks like is that you have the fixed cost on one side, which would be majorly, for instance, the depreciation of the machine. You would have the service and maintenance of for the machine, and on the other side, you have the variable costs. The variable costs are, for instance, the cost for the material, the cost for labor, the cost for energy, the cost for the consumables. And the major cost drivers are typically for SLS the depreciation of the machine, because the machines come with a high investment cost that is depreciated over a period of time, and that is typically the main cost driver. And the second biggest driver is the material. The material is the powder, where it is heavily depending on the powder density as well as on the refresh rate, as Jarek explained. So the lower the refresh rate, the lower also the cost for the powder. And the biggest difference here between SLS and then now the sinterit machines is that sinterit offers a very cost-competitive pricing solution that actually drives down the overall machine costs, so the depreciation, making it very attractive for producing these parts with sinterit.
Thank you for brilliant sum up, Marius. Okay, the next question. What are the major potential cost savings in SLS?
The major cost savings can maybe be broken down into, on the business side, the leveraging through the machine scalability, and on the other side through the technical leverages. So on the business side, you have the machine scalability, meaning if you think of a series production, you need a series of machines, but you will not need a depowdering solution. You will not need an unpacking station for every single printer. So you have a specific ratio of the number of post-processing equipment you need per printer. So this is definitely one major business cost saving. And the second technical saving potential would be, as Kuba already explained, by increasing the number of parts per print, you can significantly reduce the cost of the machine and reduce the cost of the overall use powder.
Thank you. Next question. What additional costs exist in SLS that don't exist for resin-based technologies?
Maybe we start the other way around. Unlike resin-based technologies, in SLS, you don't have any kind of cost for additional support. You don't have costs for support structures. You don't have labor costs for removing the support, because within SLS, you typically have parts that are encaved within the powder, so you don't have the additional cost there. What you do have in resin-based technologies costs are for instance, the cost for washing the parts, for post-curing the parts. You have the cost for the solvent. And this is something that you typically don't have within SLS. In SLS, you have the cost for the machine itself, and especially the cost for the powder. And here specifically for SLS, it's very characterized as the refresh rate. So the cost for the powder, take into account the refresh rate.
Okay, thank you. I like this one. What's additional costs exist in SLS that don't exist for filament-based technologies?
So here, again, similar to the resin-based technologies, typically in filament-based technologies, so FFF, you have support structures. The support structures adds additional material to support the part from underneath. This means additional cost in material and additional cost in labor to remove the support, unless you have maybe a soluble support material. But in any case, typically you have, for filament-based technologies, you have cost for the support structures. That is something that you don't have in SLS.
Thank you. And how can I avoid producing excess powder after refreshing?
Oh, this is a very important question. Basically, it all goes down to pack density, so amount of models you can fit into the printing chamber. Lisa X and Nils are new generation printers, so we can reach very high pack densities, and with it we can reach the point when where after refreshing we end up with less powder than we begin with. So increasing the amount of models is in the build volume is the key here.
Thank you. And can you use open parameters with existing powder profiles?
Yes, absolutely. You can use these profiles with these parameters with our profiles to slightly alter, for example, method of sintering for the partner for laser, the power of the laser to achieve other parameters and other characteristics of the models.
Another question, does Sinterit Studio have any auto-packing capabilities?
Yes, Sinterit Studio does have auto-packing capabilities. Sorry. This is a tool that helps us fill the entire volume with the models. You need to preset the models to have them in good orientation, and then you can multiply them, and auto-packing does all the job for stacking them together in the one volume.
What is the refresh ratio for Flexa material?
This is actually quite a simple question. It's 0%. Basically, you don't need to add any powder to Flexa after printing. You just need to sift it.
Okay, and why can I print the parts flat?
Yeah, this is also a quite important question. Sometimes you might be tempted to print big parts flat, but you might end up with bent parts. This is especially prominent with, for example, P12 or P11. Not so much with Flexas and ESD or CF, but still a bit visible. We need to start with the point, because when we go with lines or flat surfaces that start the model, we have different shrinkages in different parts of the model. So when we start with the point, we avoid it, and the models tilted by 45 degrees in each axis give us the best results.
Thank you very much. And we answer all the questions that were asked before, and now we are in open questions. Okay, so the questions asked by you during the webinar, and I will start live answers. And Kuba and Marius, if you feel okay with the question, please start answering. I will start with the first one. Are the prints with 22% refresh rate the same aesthetically and mechanically to say as a 50% refresh rate? Basically, what we recommended with 22%, it's we just recommended 22% to make sure that you will keep the constant properties, and we're sure that you're gonna keep what we promise in our specs. With 50% refresh ratio, you'll get a little bit better results, but it's not a big difference. And basically, most of the time, it's not worth to use such amount of the fresh powder. Okay, the next question. If one wants to print with all the different materials Sinterit offers in one printer enough, apart from the deep cleaning that the material change requires, can it cause actual problems to the machine?
I think I'll answer that. No, you can very easily print all the materials with one printer. Basically, a key here is to clean the printer correctly. Also, when you are going from materials with lower melting point to higher melting point, you need to be extra careful. There is also one more step, the replacement of a seal around one printing area, and that's basically it. You can use this one machine for all the powders.
Yeah, I will add just the cleaning process. It's really super fast. I mean, you need to try it, but it's like 5 minutes or 15 minutes if you're just doing this first time. Okay, the next question. Can the auto-nest functionality place and orient optimally based on number of pieces needed in the demo instead of manual placement orientation?
I will answer this one. Basically, auto-nest functionality is a helping tool that lets you pack many models in the area at once. It doesn't really take the shape of the models or the number of the models into account, but if you go with a smaller amount of models, the result of auto-nesting will be built of a lower height.
Yeah, and also answering the part with the orientation, we just, I mean, the auto nesting do not orientate automatically, because the orientation, it's a matter of the final properties and what you want to achieve with the printout. Following the very simple rules, you can have different properties of the printout, and it's more about the user. It's like what do we want to achieve? Okay, well, why can't the software automatically nest the models rather than the user need to manipulate them manually? I think we already answered these questions. Okay, let's take a look at another one. Okay, Galvano system on Lisa X, besides of better speed, have the angle effect. Because in the corners of the build plate, the laser will not have round point, but elliptic shape with decrease in accuracy and resolution. How you manage that effect? I will try to answer this question. Okay, first of all, I mean, that's something that we manage by the software and by our own optics system. And of course, it's something that always comes with the Galvo system, but you can, you can use the software and the optics system to optimize it. So there is no effect. So it's not a problem in Lisa X and Niels. Okay, the next question. What is the degradation rate of final parts over time, PA12? For example, how much time I can wear a glass frame before it will crack? Moist, sun, wind, washing with different base for cleaning. Kuba, I don't know if you want to answer this question.
Basically, we have some knowledge of how our powders printouts behave, but it really depends on what kind of elements or what kind of stress you are enforcing on the printouts. So it really depends. If you want a more specific answer for a more specific scenario, feel free to write to us in this for this specific question.
Okay, I would try to answer this question differently. I have many things printed that are basically now they have like 6, 5, or 4 years. The one that I'm using the longer, and they still in a brilliant shape, and it's all regarding the PA12. And I don't know, Marius, if you can give us a little bit more view on the PA11 aging.
I would have explained it in a very similar way to Kuba. That is, it very much depends on the stress that you are exposing it to. For a specific eye class, so eyewear, for instance, in this case, glass frames. This is something that we can take up and answer directly in let's say in an email.
Okay, thank you. Let's go to another question. Okay, how can we calculate the cost of the material consumed for nylon PA12, for example, including the refresh material and the original material? Is there a formula?
Okay, so there are a couple of approaches we can have here. We can go with the volume of the models that consumed the powder we started with. That's the basic approach. Another approach is to calculate it. Let's calculate it twice. Basically, you are printing the parts. You are refreshing the powder. You are taking the cost of refreshing the powder, and you basically divide it into two builds. This really depends on what's your approach and what's your business model. For pricing the samples in Synterit, we basically take into account what we had in the presentation. So the cost of the powder, the labor, the electricity, and the depreciation.
And regarding the formula, it's like a bit more complicated, but you can always ask Kuba to prepare the calculation directly for you, just based on your models. Okay, next question. PL smooth is just PA12 or PA12 with carbon fiber? No, it's like PA12, it's PA12, and the carbon fiber one, it's PA11. And this one has special properties, like high temperature durability, the mechanical resistance, and but it's a different material. It's a PA11 carbon fiber. There is no PA12 with a carbon fiber in our offer. Okay, how to calculate the value of the printer in 5 years from now? What is the value function of time and working hours Synterit can buy back? I will do it quickly. It's more like depends. I mean, we had some assumptions during our calculations. It's more like you need to contact Kuba for more details and help you to calculate your own depreciation based on your aspects like labor costs and power. Okay, how big are particles of powder, and can be possible to get better results with a small powder particle size to come somehow with close to resin details? Marius, can you answer this question?
And I think for this, I would have to align internally as well.
Okay. So Kuba, are you ready?
Give me a second, please.
Okay, so I will try to answer. First of all, I mean the smaller powder particles will not take us into account of quality of resin printers. I mean, it's not about the particles size. I mean, we can go lower, but it doesn't change too much. It's about the laser spot and how many particles are sintered in one move. And the quality of SLS is really good. If you take a look at the SLS, and of course the resin based printers are far better in details, but on the other hand, the durability of the printouts from SLS are far better. So it's something. I mean, it's always something for something. So we have really good quality as for SLS, like both Lisa X and Niels keep the highest industrial quality of the printouts. But if we taking into account the SLA details, it's not. It's different technology, different approach. It's different, basically, reason to have these printers. Okay, the next question. Okay, what is the rate of degradation of powder PA12 if not used over time? I see people that put powder in oven before printing. It's not a secret that it absorbs moisture, but how fast it did when proper working with powder?
Okay, I'll take this one. Basically, if you are storing the powders correctly, if you are using our buckets and if you remember to seal them correctly, you can print virtually indefinitely with one batch of powder. Sometimes, if you leave, for example, the bucket unopened, powder might absorb moisture, and then as a last result, we suggest to put the powder in oven. But normally, you don't need to get there.
Okay, thank you. Okay, what parts of the printer usually fail over time, and what is the delay of sending the part, not including shipment, the stock of parts at Sinterit, or you takes time to be manufactured?
I'll also take this one. So there are a couple of consumable parts which need to be changed from time to time. The printer will prompt you when is the time to change these parts. But for example, if there is a bigger failure, our distributors are stocked with the most of the parts of the printers, so the shipment doesn't take long at all, and most of the repairs can be very easily done.
Okay. Last two questions, I think. Okay, minimum wall thickness we can print with PA12. Okay, then it depends on the model. I mean, for larger objects, we recommended 0.8 millimeters, 0.5 millimeters. It depends on your STA, on your creation. But in smaller objects, you can have a lower wall thickness of 0.4 millimeter. Okay, are the 22% possible due to your heating system? Yes, that's something that we recommended, that we've tested for a really long time. We have systems that work on 22% refresh ratio for a really, really long time, constantly with the same powder, and it's still all fine. And we test it time to time just to make sure that even for long runs, it just keep the properties. And basically, yes, it does. Okay, another question pop up: how to minimize the porosity of the printed parts? Okay.
Basically, models printed on SLS are porous. That's not a big news. But if you want to decrease them, you need to make some sacrifices For example, if you want the models to be very tightly sintered, increasing the printing temperature is one of the options. But for example, if you are willing to go for other materials than PA12, you can go with polypropylene that has some watertight capabilities. And we have also a flexible material, TPE, which can be sealed.
Okay, thank you very much. I'm looking at the questions. Okay, only one left. What's the difference between starter PA12 and smooth PA12 powder?
Basically, these are the same. Because sintered printers are calibrated to work with the powder that has been used and refreshed. As a starter powder, we provide a powder which is exactly this, a powder that has been used and refreshed. The PA12 fresh powder is the only the refresher powder, but the starter powder is mixed with powder that's used for better results.
Okay, thank you very much. And another question is popping up. Okay, what is the temperature you use for PA11 and PA12?
Okay, I'm not precisely sure. Maybe with P11, Marius can help me, but for P12, it's 178 degrees.
And for PA11, it's typically somewhere around 185 degrees for the carbon fiber and the ESD material.
Okay, thank you. What type of paint you recommended for SLS prints? What about boilet paint, not spray? Okay, we do recommending coating that we already preparing together with BSF, and so it's the coating that you use with the primer, and then you just put the coating and put it into oven just for some time. They have a skin contact certificate, and probably Marius will be able to tell a little bit more about the coatings.
So if you're looking for let's say a different look of the part, or if you want to add additional characteristics to meet certain requirements, you can always use, for instance, the ultra cured coat F that we currently have in our portfolio to coat the SLS parts. It's it's a 2K system on a water basis, so you can apply it, and it comes in let's say the standard colors in black and white and metallic. And if you want to have, let's say, additional colors, you can always reach out to match the ideal color.
Thank you. And okay, the last question is the final question. Can we lower the powder cost with bigger bulk orders? And
I take this one. It depends basically on models. If you are going with models that basically occupy all the space in the single model occupy all the space in the printing area, well, this will be hard to minimize. But if you are going with the smaller models, of course, by increasing the trying to find the better positioning, the more optimal orientation for these models, so we can fit more of them together. So we have also some clients that asked us for preparing the simulations for sets of quite big models, but with some adjusting, it might take a bit longer than usually if you want to get very, very good pack density with more tricky models. But you can always adjust that and increase the pack density and therefore lower the cost.
Okay, and as I understand differently, the question I will try to answer differently. The bigger bulk orders, I mean, if you want to order like 100 kilograms or more, you can always contact our sales team. But I mean, the rate for the powder is basically flat, but why not just contact us? Okay, so one more question. Does Synterate will be available for collaboration in the centralized 3D printers A glasses? I don't know nothing about this project yet, and but if it's worth to attend, just please contact us, and maybe you can share more information about this, Andres. Okay, thank you. I think I just okay. All the questions are asked already. So thank you, Mariusz. Thank you, Kuba, and thank you all for attending. And I hope you like it. And please, if you have any more questions or you want to contact us directly just to see the printer, to go for live demo or return on investment calculation, just please contact us directly. And thank you very much and have a nice day.
Thank you.
Thank you very much. Bye-bye.